So this afternoon we are going to be talking about blood vessels. And this is a cool picture. This is a brain that had latex put into all the different blood vessels, and then they basically dissolved the brain tissue, so all that was left was all the plastic that was inside all the blood vessels, so you can see what they look like. So we are still in the cardiovascular system, but now we're just going to focus on the different blood vessels and how they are categorized into their different groups. So first of all, with your blood vessels, you have three possible layers for your blood vessels. So that's what you're seeing here. You're seeing layer 1, layer 2, layer 3. And this is the hollow section of the blood vessel that the blood would actually go through. And this is how your blood vessels are actually divided up into their groups. Okay. So when we look at blood vessels, the layers of the blood vessels are called tunics. So you'll see what's called the tunica intima, the tunica media, and the tunica adventitia. And like I said, this is what makes when we look at blood vessels, you have arteries, arterioles, capillaries, venules, and veins. So it's the blood vessel layers that help differentiate between one kind of blood vessel and the others. Now, like I said, this hollow area right here is called the lumen. That's what blood is actually going to pass through, and it's lined with simple squamous tissue because remember, we want to reduce that friction. Now, different blood vessels vary in the number and thickness of the layers. So for example, arteries are going to have all three layers. Veins will have all three layers. But arteries start off really large and they branch, they get smaller and smaller and smaller. As they get smaller, the layer is going to start getting thinner and thinner and thinner. And eventually you'll only have two layers. At that point in time, you're called an arteriole. The arterioles continue to branch, get smaller and smaller and smaller until you only have one layer. At that point in time, you're called a capillary. Then the capillaries will start coming back together and get thicker and thicker and thicker until you have two layers in your venule. And the venules will come together and get thicker and thicker and thicker until you have the three layers again, and they're called the veins. So, the first layer is called the tunica adventitia. That's your outermost layer. Excuse me. It's mostly collagen. Because remember, we talked about how collagen is that really, really strong protein that helps hold the blood vessels together. So this is going to be what gives the blood vessel its shape. That's this layer right here. And it also helps anchor it to the surrounding structures. Now you know that blood vessels pulse. So you know blood vessels have smooth muscle in them. So the layer of muscle is called the tunica media. So that's the middle layer, and that's the layer that's responsible for peristalsis. And it is smooth muscle. And then the innermost layer is called the tunica intima. It is purely simple squamous tissue. So if you're an artery and a vein, you're going to have all three of these layers. If you're an arteriole and a venule, you're just going to have these two layers. And if you're a capillary, you're just going to have that layer right there. So remember, capillaries are where diffusion takes place. So you have to be really thin. You have to have that one layer in order for that to happen. So what we're going to do is we're going to look at how the categories of all your different types of blood vessels. So the first thing here, some facts about arteries. I always compare blood vessels to garden hoses. We've all seen a garden hose before. And you know that when a garden hose, even if water is not, sorry, it's shaking. Even if water is not going through the garden hose is still perfectly round. Well, arteries are the same way. So I want you to think of arteries as a garden hose. The tunica adventitia is so thick, those collagen fibers are so strong, that even if you were to drain the artery would still stay perfectly round. It wouldn't deflate. Now, veins have all three layers, but veins aren't as important, I hate to say. Your body considers arteries to be more important than veins because arteries are carrying nutrients and veins tend to carry waste products. So arteries tend to be thicker and stronger than veins. And so even though they both have this layer, the collagen fibers of arteries are thicker, so this tends to stay perfectly round even when there's no blood inside of it. Okay. So like I was saying, these guys are more important than veins because they tend to carry nutrients, so they're buried deeper in the body. It's really hard to cut an artery. Usually when you cut yourself, you've cut a vein or you've cut a capillary. Right? With arteries, since these are buried deeper, you have to really, really cut into your tissue in order to cut an artery. So it's rare to cut an artery, but when you do cut an artery, you know, it can be life-threatening because of all the nutrient-rich blood that's rushing through it. So they are more important than veins, so your body's going to protect them by burying them. Also, pressures the muscles. Pressing down on them helps keep blood flowing at a high pressure and a high speed. Blood flows faster through an artery than through a vein. Because arteries are carrying nutrient-rich blood, you need that oxygen and those nutrients to hit those tissues really fast. And so they're under high pressure, and also it's like sitting on a water balloon. The water's going to shoot out. So the pressure of your muscles pushing up against the artery helps keep the blood flowing faster. Veins are carrying mostly waste products. So your body doesn't worry about the vein, how fast the blood is moving. The blood moving through veins is a lot slower than moving through arteries, because as long as the blood gets to where it's going, it's okay if it takes a little bit longer. But with arteries, they're carrying those nutrients, and so you need to get those nutrients to those tissues really fast. And so when cut, the pressure is so high that it's really hard to form a blood clot in an artery. Because as soon as the platelets find a place to hold on to, the peristalsing of the artery will just basically blow those platelets away. And so it'll pop that blood clot. So when you cut an artery, it spurts. And that's a pretty dangerous sign. You need to tourniquet it, or you need to put some pressure on it. Blood in veins is moving a lot slower. So it just kind of leaches out. It just kind of, pools out. It just kind of, makes its way out. And the blood is moving slow enough that the blood would have time to form a blood clot. And you do have 3 types of arteries. So the first one are these things called elastic arteries. Now, I don't call them elastic arteries. I call them by their other name. Because when you think of something elastic, you think of something that's really, really, really flexible. Well, these guys are the thickest arteries you have. They're the strongest arteries you have. They're the ones that are under the highest amount of pressure. So they're not really that flexible. So these, like I said, these are the largest arteries you have in your body. These are going to be the ones that are closest to the heart. So they have to be thick because they're under a lot of pressure as that blood shoots out of your heart. So the aorta is one of these. The pulmonary arteries are examples of these. Okay. So like I said, these are the ones closest to your heart. And they have to be really thick, because if these guys weren't thick, the moment your ventricles shut and the blood pushed through them, they would be under such high pressure that they would explode. So like I said, the aorta and the pulmonary artery were examples of these. Okay. And elastic arteries have all 3 layers. Okay. And they're also called conducting arteries. I like conducting arteries first, because when you conduct something, you lead something. And these are the leading arteries. These are the first arteries coming off the heart. These are the ones that are the first ones that the blood passes through when they leave the heart. So they're conducting, they're leading. Like I said, elastic makes you think that these are pretty flexible. In reality, they're not. They have to be under high, high, high pressure. They're really tight because you need the blood to shoot through them. Okay. Now, these guys have all 3 layers. They have the tunica adventitia, which is the collagen fibers, really thick, really strong. They have the tunica media, which is the muscle layer. And they have the tunica intima, which is the simple squamous in the middle. So here would be your tunica adventitia, your tunica media, and then this lining would be your tunica intima. And as they leave the heart, they're going to branch. And every time you branch, you get a little bit thinner and you get a little bit thinner. No, excuse me. With lasers, they can actually measure the thickness of the different layers. And so when these guys branch enough, what starts to get thin first is the outside layer. And so as long as you're a certain thickness, as long as your tunica adventitia is a certain thickness, you're called an elastic artery. But once the tunica adventitia gets thin enough, it's now called a muscular artery. These guys still have 3 layers, but the tunica adventitia is very thin. Okay? To be an artery, you have to have all 3 layers. You have the tunica adventitia, the tunica media, and the tunica intima. Muscular arteries still have a tunica adventitia, but it's almost all gone. Remember, the tunica adventitia is collagen fibers. Well, muscular arteries get their name because they're in the muscle, so they don't really need that thick layer of collagen because the muscle itself will protect these arteries. Okay? So these are the ones that are taking the blood to the organs. Okay? So your ulnar artery would be an example. Your brachial artery would be an example. These are the arteries that are in the artery packet. Now these will also continue to branch and branch and branch and get thinner and thinner and thinner until the tunica adventitia is gone. Once the tunica adventitia is gone, you cannot call it an artery anymore. To be an artery, you have to have all three layers: tunica adventitia, tunica media, and tunica intima. But these guys are going to branch inside the organs and get thinner and thinner and thinner, and eventually the tunica adventitia will be gone. Once you only have two layers, at that point in time, you're called an arteriole. Right? So arterioles are your smallest arteries. Now remember, for years we just had arteries, capillaries, and veins. But once we got the technology, excuse me, to see how the layers changed, that's where we came up with this subclassification. To be an artery, by definition now, you have to have all three layers. Arterioles only have two layers. They have the tunica media and they have the tunica intima. The tunica adventitia is gone. So we can't call it an artery anymore. So by new definition, it's called an arteriole, which means little artery or baby artery. Right? Now, these guys will continue to branch. And as they branch, the tunica media will now start to get thinner and thinner and thinner. The tunica media is going to start to disappear until eventually the tunica media is gone. Okay? So when the tunica media is gone, you only have one layer. To be an artery, you have to have three layers. To be an arteriole, you have to have two layers. And to be a capillary, you're only going to have one layer. Okay? With the capillaries, these are the smallest blood vessels you have. They are pure tunica intima. Remember, tunica intima is your simple squamous tissue. This is where all diffusion is going to take place. This is where the gas exchange will take place. This is where the nutrients and waste product exchange will take place. Okay? It is only the tunica intima. Okay? Now, so therefore, capillaries do not have a tunica media, so capillaries cannot periostose. So, periostosing is what moves the blood through the blood vessels. Well, capillaries can't move. Capillaries can't pulse. And so if you'll notice here, you never have just one capillary. Here's an artery. Here's the arteriole. Here's the capillary. So the arterioles will branch into what's called a capillary bed. And blood moves through capillaries by pure pressure. It's like going from a 4-lane road to a 2-lane road to a 1-lane road. Your blood pressure builds up. Okay? You get irritated. So without the tunica media, your capillaries cannot periostose. Okay? Again, this is where diffusion is going to take place. So the cell must be only one layer thick. And like I mentioned, they form large networks between arteries and veins, which are called capillary beds. So arteries are under high pressure, but capillaries are actually under even higher pressure than arteries if you look at the surface area, because capillaries cannot periostose. The blood cells have to be pushed, have to be forced through the capillaries. So capillaries are under extremely high pressure in order to make sure that the blood keeps flowing. And so this is where your gas exchange is going to take place. So again, you have an artery, which is 3 layers. It'll branch into an arteriole, which is only 2 layers. And it will branch into your capillaries, which are 3 layers. Now your capillaries will begin to fuse back together as well. And that's going to form something called a venule. Okay? So these are going to fuse back together in order to form something called a venule. And venules are, remember, arteries take blood away from the heart and veins bring blood back. So arteries have 3 layers, veins have 3 layers. Arterioles have 2 layers, venules will have 2 layers, and then your capillaries are only going to have 1 layer. Right? In the case of capillaries, you do have 3 kinds of capillaries, and it's going to be based on the job that they do. So, in the case of the type of capillaries you have, 99% of all the capillaries in your body are called continuous capillaries. This is what you would think of as a normal capillary. When people talk about capillaries, this is the group they're talking about because it continues the flow of blood. So 99% of all the capillaries in your body fall into this category. You go from artery to arteriole to continuous capillary to venule to veins. Now in your body you have two other types of capillaries which have a little bit of a different job. Okay? But 99% of all capillaries are what we call continuous capillaries. So usually when we're talking about a capillary, this is the group we're talking about. Now, in the case of capillaries, this is where diffusion and osmosis should take place. Well, some of your organs filter. So you need to have more stuff come out of your blood vessels in those organs than you would in a regular organ. So you have a special type of capillary. These capillaries are called fenestrated. Remember, fenestrated for filter. So these capillaries are found in organs where filtering occurs. Now, you still have these. These are found in every single organ in your body. But in the case of your filtering organ, they will have these. This is where they get their nutrients from, but they will also have these. Fenestrated capillaries allow for more stuff to leave your blood than what would normally leave your blood. So in the case of your stomach, you're just going to have continuous capillaries. But in the case of your kidney, you'll have continuous capillaries and fenestrated capillaries because your kidneys have to filter out something called urea. Your spleen has to actually filter out the red blood cells. So continuous capillaries are found all over, but organs that filter also have what are called fenestrated capillaries. Now, in your bone marrow, remember bone is where your blood gets made. And so we talked about how the blood cells have to enter your bloodstream. The blood cells have to go inside of a capillary. So in your bone marrow, you have the third type of capillaries, which are called sinusoidal. Remember, sinus means it's a hole or a cavity. Sinusoidal capillaries are also called leaky capillaries. Well, if you think about something leaking, you think about it coming out. Well, in sinusoidals, this is where the blood actually gets inside of a blood vessel. So to me, that's not really leaky, but they're called leaky capillaries. So your bone marrow will still have continuous because your bone marrow needs nutrients and get rid of waste products. But your bone marrow will also have sinusoidal, which is this leaky capillary. It has openings in it, and this is where the red blood cells and the white blood cells squeeze their way into your blood vessels.